In this problem, we are given a circuit diagram right here. We need to use the node voltage method to find the power absorbed or delivered by the dependent source PDS. What PDS means is the power. The DS is a subscript, so this stands for the dependent source. And the dependent source is all the way to the right here, because the current is going to be flowing through here. Some of it's going to go through here, some of it's going to go through here, but this is what's drawing the power. So we're going to be looking at that in the end. We know our power formula to be, or one of the ways we can write the power formula to be voltage times current. So we're going to need to find the current flowing through here as well as the voltage. Well, we know this is equal to our voltage. So we need to find our I naught. We need to find the current flowing through here, and that's a perfect setup for our node voltage method. So starting our node voltage method, we have to pick a node. This is the node I'm going to be working with, and we're going to start out by looking at the step 2. I've also included this little picture right here, as well as the steps to solve this specific example. They don't solve the example we're currently working on, however, they're a good base we can kind of look around and form to comprehend this example. First, we are going to see that we have a voltage right here, and our voltage is going to be going across this 10 ohm resistor, and some of it is going to go into here. Since this is in series, the voltage is going to be different. The voltage is going into the node, so what we're going to have here is a V naught, and I'm going to be calling our voltage right here V naught, just to keep it similar with the I naught, minus our 160 volts. This is the source voltage coming in, and this is all over the 10 ohm resistor. From here, we're just going to look at this voltage that's going this way. It's going away from our node, so we're going to have a plus V1 over our 100 ohm resistor. Now we want our V1 minus V2 over the resistors between. So this is basically our V2 right here. We have 150 times our I naught, and our V naught is kind of like the V1 in the equations. I'm going to correct this. I accidentally put V1 here. That should be a V naught. But for this, we're going to have a V naught, and this is a minus 150 times our I naught. And this is all over the 30 ohm resistor. I did make a slight mistake though. This is actually not over the 30 ohm resistor. It's over a 50 ohm resistor, because these two resistors are in series. And since they're in series, we can add them up. So this is actually going to be over 50, like this. Now we need to solve for I naught. Our I naught is right here. So we're going to say that our I naught is equal to, and then the formula, Ohm's law for I naught, is voltage over resistance. We know our voltage to be V naught, and it's going to be over the resistance of 100 ohms. When we look at this though, we know that our current is going up. We know that our voltage is going down, like this. Since they're going in opposite directions, this is going to be negative right here. So we have a negative V naught over 100 ohms. Next, I'm going to simplify the top by multiplying everything by 100. Also, this should be set equal to 0, because all currents going into the node, according to Kirchhoff's law, is equal to 0. So I'm surrounding this and I'm multiplying everything by 1000 ohms, and then I'm going to combine like terms and then go from there. And from here, we're just going to plug in our I naught that we found. So if we do this, we're going to get a 13 V naught minus a 300, and this is over a 100 ohm resistor, being multiplied by a negative V naught, and this is to the volts set equal to 1600 volts. So this is what we're going to get, and we can cancel some stuff out, so get rid of these zeros. I made a mistake in the unit somewhere. This resistance is not supposed to be here. We won't look at that for now. It doesn't really affect anything, but combining these negatives, we get a positive. If we do this, we are going to get a 13 V naught plus a 3 V naught, and this is volts, is equal to 1600 volts. If we add these together, we're going to get a 16 V naught is equal to 1600 volts. And then we can write that our V naught is equal to 100 volts. So this is the answer for V naught. So we have the V naught going through here. This is 100. However, we still don't know what this voltage is, nor do we know the current flowing through it. So to find the voltage for it, you know this is V2, we need to find our I naught. Well, now that we have our V naught, we can just plug this into here. So we're going to get that our I naught is equal to negative 100 volts divided by 100 ohms. Volts over ohms is amps, and 100 over 100 is just 1. So we're going to get that our I naught is equal to negative 1 amps. This is our I naught. So that means that the voltage of V2 is going to be negative 150 volts. We found the voltage. Now we need to find the current flowing through it. Well, we know that the current comes through this resistor and goes down this way. Also, our voltage goes into the positive and out of the negative. So we need to find the current. We're going to, again, kind of use this formula right here, where we have our I naught, and we'll call this I 30 ohms because it's over the 30 ohms. And we're going to set this equal to our V1, so the voltage right here, minus our V2, which is the voltage in this side, over the resistance that it's over. And since it's in series, again, this is over a 50 ohm resistor. We found this V0 to be 100, so we're going to have 100, and this will be minus a negative 150, and up here it's all volts. Volts over ohms is again amps. We're going to add these two together, so we're going to get 250 divided by 50, and this is going to give us a current of 5 amps. So now we know the current flowing through right here. I is equal to 5 amps. This is also the current flowing through here and here, again because they are in series and current flow is the same throughout a circuit in series. But we do have the part that matters, which is this part. We found our I and we found our voltage. So we just need to multiply them together. When we multiply them together, put it in here, we are going to get a negative 750 watts. And that is the answer to this problem, as well as how to do it. If you want more problems like this, there's a playlist in the description. Also, if you want notes to help do this problem, other problems, or study for exam, they're also linked below in the description.